Hello everyone. Now we have to going to see about what is the system of equations in consistency and uniqueness. What is meant by consistent and inconsistent? Consistency means it has either unique solution or infinitely many solutions. If it has no solution means it is called an inconsistent solution. We have some. First one, consider the system of equations is a11x1 plus a12x2 is equal to b1. Likewise, a21x1 plus a22x2 is equal to b2. Each equations are called a straight line. These equations having three possible cases. First case is unique solution means if the lines are intersects. Infinitely many solution means if the lines are coincides. No solution means if the lines are parallel. We have some problems based on consistency of the system of equations. Yes, consistency. Check the consistency of the equation x minus 2y is equal to minus 1 and minus x plus 3y is equal to 3. We have two system of equations. Now we have to substitute x is equal to 0 in equation 1. Likewise, y is equal to 0 in equation 1. Finally, we get x and y values. Now we got the intercepting points. The intercepting points are 0, 1 by 2 and minus 1 is 0. And likewise, we have to substitute x is equal to 0 in equation 2 and y is equal to 0 in equation 2. We have we have two values for x1, y. X value is minus 3, 1 y value is 1. The intercepting points are 0, 1 and minus 3, 0. Now we have 4 points 0, 1 by 2, minus 1, 0, 0, 1, minus 3, 0. Now form the graphical form. We have x-axis, y-axis. Now form the straight line. Finally, the lines are intersecting. Then the system of equations having exactly one solution. We have exactly one solution means the system of equations is called consistent equation. Now we are going to see about the second problem. Check the consistency and nature of the solution of the system of equations x minus 2y is equal to minus 1 and minus x plus 2y is equal to 1. Likewise, substitute x is equal to 0 in equation 1, y is equal to 0 in equation 1. We'll get x value is minus 1 and y value is 1 by 2. Now the intercepting points are 0, 1 by 2 and minus 1, 0. Likewise, substitute x is equal to 0 in equation 2 and y is equal to 0 in equation 2. We'll get x and y points minus 1 and 1 by 2. The intercepting points are 0, 1 by 2 and minus 1, 0. Now we have formed the graphical format. We have the line. Here, the lines coincide. The system has infinitely many solutions, and infinitely many solution means absolutely the system is called the consistent equation. Next one, check the consistency of the system of equations x minus 2y is equal to minus 1 and minus x plus 2y is equal to 3. Now substitute x is equal to 0, same procedures. X is equal to 0 in equation 1, y is equal to 0 in equation 1. We'll get y value is 1 by 2 and x value is minus 1. The intercepting points are 0, 1 by 2, minus 1, 0. Likewise, x is equal to 0 in equation 2, y is equal to 0 in equation 1. We'll get y value is 3 by 2 and x value is minus 3. So the intercepting points are 0, 3 by 2 and minus 3, 0. Now we have the parallel equations. Here no intersecting equations. We will get the parallel system of equations. If the lines are parallel means the system has no solution. Given the system has no solution means the system of equations are called inconsistent equation. Now we have an important theorem is called fundamental theorem. Fundamental theorem is called a fundamental theorem is known as system of linear equations is consistent if and only if the matrix A and the augmented matrix A given B have the same rank. Also, the system has a unique solution means we have rank of A is equal to rank of A given B is equal to n, where n is the order of the equation. We have Gauss elimination method using consistency. Check the consistency of the system of linear equations. We have a three system of equations and four unknown values. X minus 3y plus 2z plus 2w is equal to 1. 2x minus 2z is equal to 3. 4x minus 6y plus 2z plus 4w is equal to 6. Now the augmented matrix is known as 1 minus 3 2 2 1. Likewise 2 0 minus 2 0 3, 4 minus 6 2 4 and 6. Now we have to make first column, second element and third element should be 0 by using R1. Likewise R2 can be written as R2 minus 2R1, R3 can be written as R3 minus 4R1. Now we have no changes in first row and second row, third row we have some changes. That is first element is 0 by using R2 and R3. Likewise, R3 can be written as R3 minus R2. Now we have all the elements 0 except last element of the R3 row. Now, if the elements are 0 means we have formed an echelon form, but here the row R3, given R3 is not possible because 0 is not equal to 1. It is not possible, so the system of equations is inconsistent. If all the values are 0 in last row now, 0 is equal to 0, it's possible. So the system of equations are consistent equations. Okay. After consistent, find the value of x1, four unknown values x, y, z and w. Now the second problem is x1 minus 3x2 plus 2x3 plus 2x4 is equal to 1. 2x1 minus 2x3 is equal to 3. 4x1 minus 6x2 plus 2x3 plus 4x4 is equal to 5. Now same procedure, form the matrix form, then form the augmented matrix, then we have to go about first row of the element should be 0, first column of the element should be 0, and after that we have to make R3 should be 0. Here all the elements should be 0. If all the elements should be 0 means the form is called echelon form. Now we have to find the equations, find the values of x1, x2, x3 and x4. Now form the equations of first row and second row. Now we have x3 and x4 are free variables. Now the system of equations are consistent and it has infinitely many solutions. Third problem will be different comparing first and second problems. What are the conditions must B1 and B2 satisfy for the system to be consistent? We have two system of equations. We have no values of B1 and B2. Same procedure, form the augmented matrix. After augmented matrix, we have to find the value of B1 and B2. Now B1 as B1 and B2 as B1 by 2. So the system of equations are consistent. Yes, now for what value of k will the system is consistent? Now the augmented matrices of the form 1, 3, 4, 9, 1, k minus 3, 7, 2. We have k value here. Now we are going to find the value of k. By using R2 and R3, make it as first column, second and third element should be 0. After that we have to form the upper triangular matrix. After upper triangular matrix, use back substitution method. After back substitution method, find the value of k. Now k value was 53 by 4. These are the main application problems. This problem belongs to a factory produces, that is product problem. A product is, we have A, B, C products and we have machine time and raw material. Okay, then form the equations. Given data, we have three unknown values, three unknown equations. We have formed the three system of equations like x plus y plus z is equal to 5, 2x plus y plus z is equal to 7, x plus 2y plus z is equal to 6. We have three system of equations. Already we know about how to find the matrix. We have the matrix form. We have the augmented matrix like 1 1 1 5, 2 1 1 7, 1 2 1 and 6. After that we have to form R2 and R3 will be 0 by using R1, then form the upper triangular matrix. After upper triangular matrix, by using back substitution method, we'll get all the values of x, y and z. These are the unknown values. Okay, thank you.